and in this video we're going to discuss the optic pathway and the associated lesions of the optic pathway. So basically what we're going to be looking at today is after the eyeball creates an image in the photoreceptors, the rods and cones in the retina, that information has to make it to the brain some way, somehow. And that's what we're going to be looking at. We're going to look at the pathway it takes, and then we're going to make some disturbances of that to help reinforce that. Some of you are in programs that might need to know this as well, various healthcare programs, and that will be useful as a tool to go back. So what we want to begin to do is draw out the pathway. So to do that, let's just begin and make a simple drawing here of the backs of the retina on two eyes, a right eye and a left eye. And then I want to connect those with some optic nerves. So I'm going to draw our optic nerves here, and then I'm going to bulge that out, and then we'll curve that back around again, and we'll do those bulges at the back. Let me clear this up just there. That's a little bit better. So what we want to do is label the information, the anatomy and the visual field information, what we're looking at, and then we'll go from there. So the first off, we know we're looking at the retina where our rods and cones are. The ganglion cells will create the fibers that create the optic nerve, which is cranial nerve number 2. And then when that, between this optic nerve here, there's an area called the optic chiasm. And then there is the optic tract, of which there are, of course, lefts and rights of the optic nerve and optic tract. And then at the back here, I have drawn the lateral geniculate nucleus. And what this is part of the thalamus where the visual information is going to travel. So what we're going to do, let's use a red, red here, and we'll draw the medial visual field, or sometimes called the nasal field. And then we're going to draw in green the lateral visual fields. And this information strikes the retina different. It's important to note that as images strike the retina, light from the left side of an object will strike the right side of the retina, and light from the right side of an object will strike the left side of the retina. So anything on our lateral visual field will strike the retina and the medial side. And that will be true on both sides of the eyeball. Whereas medial visual field information will strike the eyeball on the lateral side of the eye, creating an inverted image. Now what happens is when this information is made by a photoreceptor, and I am going to do a video on that soon, I don't know how soon, but I would love to do that. What we're going to see is how that gets there. The photoreceptor creates an image. Now let's follow the medial visual field information as it projects to the lateral geniculate nucleus. And so we're going to take this neuron, it's going to enter the optic nerve, it's going to stay on the same side when it gets to the optic chiasm, and that's important. That medial visual field information, the neurons carrying that information never cross over. They do not cross over. But lateral visual field information neurons, when they hit the optic chiasm, they will in fact cross over. So if it comes in to the left eye and we go to the right side, what is going to occur is lateral visual field information come from the left eye will project over to the lateral geniculate nucleus on the right side, and vice versa. You're going to have the right eye, that information is going to cross over and it's going to synapse here. Now there are some important things that happen. I'm just going to basically mention that there's some neurons here that pick this information up at the lateral geniculate nucleus, and where that is going is essentially going to be the occipital lobe. The occipital lobe of the cerebral cortex is going to perceive the information. So what we have created now is the pathway itself of information coming and going, and how it got to the brain. So now what we want to do with this information is I'm going to clear out this side of the screen now and just kind of clear that off so that we can have this as something to look at. Because what we're going to do is we're going to now create some lesions, damage this pathway, and help you guys understand a little bit of a lot of the clinical significance behind this. Why is it that you're actually learning it? So what we want to do, let's make a lesion. Let's say we have lesion number A, or lesion letter A, right? Lesion A. So we have a left eye and we have a right eye that I am looking at here. So my left eye and my right eye. Now they each have a lateral visual field and a medial visual field on those eyes. And what we're going to do, lesion A here is a lesion of the optic nerve on the right eye. All right, this is a right eye lesion. So if we were to check like a doctor and start with our doing our eye exam, starting with the left eye and going to the right eye, and lateral visual field of the left eye, and we follow this information, let's do that. Lateral visual field information, we hit the retina, we're good. We go down the optic nerve, we're good. Optic chiasm, we're still good. It's not hit the lesion, and it made it all the way to the lateral geniculate nucleus on the opposite side, so that was called the contralateral side. And so that information is fine. Medial visual field information of the left eye also passes all the way to the lateral geniculate nucleus unabsconded. So now let's take the medial visual field information, starting now as we go to the medial visual field information, lateral visual field information. So let's check medial visual field of the right eye, and the medial visual field information hits our lesion. So we're going to color this in, showing that there would be blindness in the medial visual field there, and we would not be able to see. Now when we hit the lateral visual field of the right eye, we also see it hits the lesion too. And the fancy word for this, guys, is right monocular blindness. If lesion A happened on the left side, it would be that the left eye was blind, leaving the right eye visible. So let me also kind of move this right, because we're going to need this in just a minute. So let me add right here as well. And let's do another lesion. Let's do a lesion B, where we take out the fibers crossing the optic chiasm. So let's draw what we did above. Let's have our eyeballs here. Let's have our lateral and medial visual fields associated with this lesion. Now, we'll start off again, guys. Lateral visual field is what we're testing for on the left eye, and we see that lateral visual field information, we hit the optic chiasm here. Lateral visual field information of the left eye is definitely obstructed, and we're not going to see that. Let's check the medial visual field information of the left eye, and we see that it passes through completely fine. Let's check the medial visual field information now of the right eye, and we can see that lesion B medial visual field is fine, but when lateral visual field information hits the lesion. So now what we have is this blindness in the lateral visual fields of both eyes, or this kind of bitemporal hemianopia. Let's also take a lesion here. Let's do a lesion here, lesion C. And if we were to look at a lesion, a damage to the nerves here, lateral, medial, medial, lateral, we will see something very interesting. Now, because the brain gets information from both sides of the visual fields, giving us depth of perception, depth of field, what we've got is that the right optic tract receives information from the left eye and the right eye. And this gives something very interesting. On the right side here, if you have damage to the right optic tract, then information on the left side of the body will always be taken out. Let me show you why. So what happens is, if I take my my lateral visual field information and we hit the lesion, so the lateral visual field of that eye is fine. Now we're beginning to look like that first lesion, and we need to see what else is going on. Now let's look at the medial visual field information. It went okay on the left eye. There's no obstructions. Well, the medial visual field information now on the right eye is also messed up. We see it doesn't go through. And now on the other side, we see that the lateral visual field information continues on over without hitting lesion C. So you have what is called a contralateral homogeneous hemianopia. Contralateral because it's on the opposite side. The damage is on the right, so we have loss of vision to our left. Contralateral. Homogeneous, it's on the same side. Hemianopia, we've lost part of our vision. So tunnel vision is resulted to damage to the fibers crossing optic chiasm. And if we also damage, guys, the left optic tract, we would be having the opposite problem here. And there are a variety of things that we can look at here. If we were to damage and do this lesion here, let's say I had a lesion D, you might very well predict lesion D and its impact. Well, this person would be completely blind. No information would ever be able to get to the lateral geniculate nucleus to be perceived. So really, once you understand how the fibers go, it is relatively easy to predict what the impact would be on that pathway. So a very important thing to know clinically, as you might see, like lesion A might be caused by damage, injury, accidents. Lesion B is commonly caused by two big things. There's an artery that sits in this area called the anterior cerebral. This is one of the branches off the cerebroatrial circle, or the circle of Willis. Another common thing is just behind here is our pituitary gland. And the anterior pituitary, when it has a tumor in it, it will swell and compress the fibers crossing optic chiasm, causing tunnel vision. The rest of these can cause by a variety of injuries, infection, vascular difficulties, issues like that. So there's a variety of others that can happen after the geniculate nucleus. You can have a variety of other things, but these are just the central pathway issues that I want to discuss today that really can help you emphasize what it is you're learning and why you learned it. So I really hope you found this video helpful. Please don't forget to comment, like, and subscribe to my videos. Always helps. Thank you guys for watching, and I really hope you enjoyed it. Please let me know some topics you would like to see me make in the future. And thank you very much, and I look forward to the next video and seeing you guys there. Thank you.